Mr. Sanjay Kaur Chaudhary graduated in electrical engineering from Jadavpur University in 1987 and thereafter completed masters in power system engineering from IIT Kharagpur. He has been in the business of electric power transmission and distribution for the last 31 years, working on electric power distribution with CSC Limited. In the last 5 years, he has introduced the concept of asset management and regime formulation in CSC. After 22 years in line function job, Mr. Kaur Chaudhary switched to a different role and currently he is looking after learning and development, talent acquisition, knowledge management, infrastructure development in HRD department as Deputy General Manager. Mr. Kaur Chaudhary has co-authored a book, Manual on Transformer, published by Central Board of Irrigation and Power, Ministry of Power, Government of India, and has served as a member on the Transformer panel of the Bureau of Indian Standard. Mr. Kaur Chaudhary is an active member of IEEE from 1989 and he has served in several roles starting from Secretary and Chair of TES Chapter, Secretary of Kolkata Section, Vice Chair of Kolkata Section, Chair of Kolkata Section till 2020. So he has been in numerous roles and right now he is our Region 10 Industry Relation Committee Chair. Sir, welcome and over to you.
Good afternoon. Can you hear me, Krishna? Am I audible?
Yeah, you're audible.
Okay. Good afternoon to all the dignitaries present here. I can see Chair of Kolkata Section. I can see Mr. Sanjay Mukherjee, who is the Executive Director, Distribution Technical at CSC, and one of today's speakers. I can see Mr. Ganguly also. He has joined perhaps by this time, Nilanjan, Susanto, and all my colleagues at IEEE and CSC. It's my privilege to be invited to be present at the inaugural session of Region 10 sponsored Industry Academia Dialogue Forum on knowledge sharing with focus on basically what industry is doing today. You see, during my last 30 years, my stint with the power utility, what I have seen is that for centuries together, industry and academia existed as two different silos and without having a bridge between them. What I mean to say is that there was no collaboration between them. One is strongly guarded from the other, and what one is doing, the other is not aware, and that too intentionally. Now, with the turn of the century, and we are into the 21st century where knowledge is available at the click of a button, and the days of silo operations are gone. And we are into an era where free-flowing knowledge dissemination is the order of the day. So collaboration between the two knowledge centers, that is the industry and the academia, is bound to happen. And IEEE Region 10 is more than happy to act as a catalyst in this journey. Today's workshop, or what do you call a seminar, half-day seminar, is basically a first baby step in that direction. What I can assure you that the next year also, this dialogue forum will continue, and I would expect few more such seminars, half-day seminars, maybe visits, maybe visit to a Industry 4.0 applicable factory or something like that, or a research lab, where you can share your knowledge, where you can see where the YPs, particularly the YPs and the students, can have a look how our Industry 4.0, what is IoT, what is IT. So with this focus in mind, when I took over as the chair of the Region 10 Industrial Relation Committee, my prime responsibility was to see that the bridge between the academia and the industry is established by way of dialogue forums, by way of, say, innovation councils. And Kolkata section has been the first to start this activity on behalf of Region 10. With these words, I would wish this conference or a half-day seminar all success and request Kolkata section to carry on such activities in the coming year too. And I can assure that Region 10 will extend necessary financial help for conducting such sessions. Thank you very much. Thank you, Suleshna.
Thank you, Sanjayda, and thank you for your support and guidance as always. Now I would like to invite Dr. Shushmita Mitra, Chair, IEEE Kolkata section. Shushmita Di is a full professor at the Machine Intelligence Unit of the Indian Statistical Institute, Kolkata. She is ranked 935 among 2% scientists worldwide by Stanford list and on the domain artificial intelligence and image processing. She is a fellow of IEEE, fellow of the INSA, fellow of IAPR, INAE, and NASI India. Whenever I introduce Shushmita Di, the list goes on and on. She is the recipient of prestigious Desi Bose National Fellowship in 2021, member Inter-Academy Panel of Women in STEM. She is IEEE CIS Distinguished Lecturer. Her research interests include data science, pattern recognition, bioinformatics, soft computing, and medical imaging. And those who have read Leelavati's Daughter will be knowing much more than what I just told you now. So I won't take much more time. Shushmita Di, please, you to address the audience.
Thank you, Sudeshna. So can I share my screen?
Yeah, Shushmita Di, I'll stop sharing.
So a very good afternoon to all of you, to all the delegates and my colleagues and good friends. So since I saw that the topic was Industry 4.0, so this is very much, then I looked up, I was not aware of this term actually so long. So then I checked and found that it was very much related to what I do. So I couldn't resist sharing a little bit of what I know about it in very short. So, what digitization implies? So AI is supposed to be the new electricity in this revolution. What electricity was in the last century has been taken up by AI in this new industrial revolution, and data is said to be the new fuel. So that is as coined by Andrew Ng, a very well-known personality. So learning is essential to build any smart system, and all these cyber physical systems are connected throughout in the internet by the Internet of Things, and it is creating an exponential growth in data. So as data grows, we come up with big data. So now AI is a superset of machine learning. Machine learning is again a superset of deep learning. So big data with the worldwide availability of increasingly bigger data sets, high computing power, efficient computing, efficient low-cost algorithms, and access to cloud computing. Now we've got a lot of interest in the use of learning and digitization using all sorts of data. And big data is dependent on the 7 V's, which are the volume, velocity, variety, veracity, variability, value, and visualization. We won't go into those details. So we also need explainable, extensible, and reproducible research. And these are through manipulations involving metadata that remains accessible, interoperable, and reusable. So some of the practical problems faced in the industry academia collaboration as we face, I am in Indian Statistical Institute. So when we ask for projects from government, there are delays in fund release. Then if we go for any sharing of data, we have the data privacy issues, security, sharing issues. For example, I work in the medical domain, biomedical imaging domain. So there are protocols at institutional levels, and coexistence of a medical hospital and a university together is lacking. So this kind of collaboration faces these kinds of bottlenecks, which industry can help overcome, of course. And there is also a very different way of looking at things from the academic point of view and the industry point of view. Whereas you look at in industry, you look at products, we look at publications, and that is where our languages do not match. So we need to rethink and re-establish the collaboration at various levels. And after that, I just introduce a very small example, just a very small story. Let's say the story goes like this. A father and a son are driving in a car. They meet with an accident. the father dies, the son is seriously injured, the son is rushed to hospital, emergency surgery is necessary. Okay, so you just imagine the situation. Then the surgeon arrives, refuses to operate, says he is my son. So what does immediately come to your mind? You get confused. But the thing is, the surgeon could be the mother. That is the implicit bias. Human minds do not associate certain leadership roles with the female gender. So this is what is implicit bias, and industry often lacks this. I mean, has this, and you can see very few women in the leadership positions. It's mostly male dominated. You need to have this inclusiveness in any kind of industry. So this is actually a built-in mental setup due to societal norms. As example, when we talk in English language, we use the masculine pronouns as he, him, his. We don't use her. But today in the Western world, insistently we use her and she in any manuscript. So that is where some kind of a bias remains. In Indian Statistical Institute, we are trying to solve this industry academia gap. Of course, the government is also very much in full swing in supporting this. So we have set up a technology innovation hub on data science from the Department of Science and Technology. We have formed a Section 8 company, which is Ideas. So we also encourage startup industrial projects and engineering applications. And so that some of our areas are medical imaging, remote sensing, data science, machine learning, AI. And digitization in the COVID scenario has been very important. It has changed the landscape of research, and because digitization existed, that's why we could continue working from home. Now it is possible to connect remotely to anybody, anywhere in the world in a cost-effective manner. We can have online interactions, meetings, discussions, lectures. There's no more anything like fixed office hours. This is the result of this fourth industrial revolution. So I wish your conference, this half-day talk seminars, a great success. I hope we do come up with positive steps towards solving this industry academia gap. Thank you.
Thank you.
I'm sharing, no? Thank you, Sudeshna. You can continue.
Thank you, Sushmitani. Now we invite our first speaker of the day, Mr. Sanjay Mukherjee. Mr. Mukherjee is presently Executive Director in CSC Limited. He has 30 years of experience in the areas of transmission and distribution network planning and designing, commissioning, technology adoption, automation, and thermal power project development. He is passionate about smart grid applications and is responsible for its deployment in CSC. Sir, welcome to this forum, and over to you for your session.
Thank you. Thank you. Can I share my screen? Give me a moment.
I'll stop sharing.
Is it visible? Is my screen visible?
Yes, Sanjay, it's visible. Yes, you can go on.
Speaking on mute. It's visible.
Okay. Thank you. I thank IEEE Sanjay Kaur-Chaudhary, who happens to be my friend and schoolmate also, for giving me this opportunity. And I somewhat feel shaky to be present amongst so much of learned dignitaries in this panel. Bear me out for the next maybe 30-40 minutes. Anyway, I'll start. My topic of today's discussion would be Industry 4.0 in distribution companies. In DISCOM, because I represent a distribution company, so what all we are doing and what all may be the applications of Industry 4.0 in DISCOM would be my topic of discussion today. See, when we talk about industrial revolution, if we look at what was Industry 1.0, or some people like to call it 1.2. So some noise is coming. If the others may kindly be on mute, it would be great. Thank you. So Industry 1.0 was the mechanical production machines powered by water and steam. Then around 90 years therefrom, experts say that it was Industry 2.0, which introduced mass production lines powered by electric energy. Then again, in around the 1960s, Industry 3.0, where the use of electronics and IT further progressed in autonomous productions. Currently, we are talking about Industry 4.0 or 4.0, which is IoT, the Internet of Things. Someone also like to call it Industrial Internet of Things, IIoT. But for the sake of today's discussion, I'll refer to IoT only. So IoT enabled cyber physical systems, then analysis on anything, anywhere with minimum infrastructure. And talking about its application in the field of electricity, the electricity landscape is a prime example of the Industrial Revolution 4.0, as it is undergoing transformation that are more complex than ever. For the evolving technologies, emerging innovative business models, and shifting regulatory landscapes. For the benefit of all present here, I understand many students are also here. Electricity business, power distribution in this country is fully regulated. Now, this industrial revolution or this 4.0, whatever we may like to call it, is fueled by a combination of disruptive technologies and social innovations. Madam Mitro touched upon some social points which I liked very much. So taking cue from that also, most new technologies and social innovations are disruptive on their own. The combination of them is even more powerful to create a perfect storm of disruption. See, if we talk about technology on one hand, these may be digital twins, 3D printing, crowdsourcing, then mobile technology, co-creation, all such kind of things. On the other hand, there may be the social robotics, gamification, sharing economy, social media, digital platforms, all these kind of things. So what I mean to say in this slide is that traditional and digital infrastructure is one part. The other part is the human and social capital. And as we progress every day, these two aspects, that is technological innovations and social innovations, they are overlapping more and more to create this perfect disruption or the storm, as you may call it. Now, going forward, what are the growing responsibilities of power distribution companies? See, the traditional power system was what? There was a generating station. We used to generate power, mostly thermal. Then there were the transmission companies, transmission lines carrying electricity unidirectionally from the generating centers to the load centers. DISCOM was sitting in between, supplying power to the end consumers. Now, the power system looks different. There are transmission companies, there are DISCOMs, there are the consumers, but the consumers are also now generating. They are having distributed energy resources. There are EV charging stations, there are battery storage systems, there are windmills, so many things. The list is long, and power is flowing in both directions in every node of the network, which makes the network management more and more complex as we go along. So the conventional roles of DISCOMs, which were connection and disconnection of the energy resources, distributed energy resources, planning, maintenance, and management of networks, management of supply outages, energy billing. Now, over and above all these, while these remain, over and above all these, the emerging additional roles of DISCOMs are the peak load management, then the network congestion management, as I told that every node is now experiencing or going to experience more and more power flow in both directions. Then reactive power support, then maintaining power quality. Power quality is becoming very, very important as we progress, because all kinds of loads, all kind of controls, all kind of technologies are what should I say, are non-linear in nature, thereby injecting harmonics of all kinds, spikes, sags, swells, everything into the system, which is becoming more and more challenging for the power system operators to maintain good quality power, because ultimately the end consumer, they don't understand what is happening behind the scenes. They don't understand sags, swells, harmonics. It is the prime responsibility of the distribution companies to maintain good quality power at the consumer end. Now, with more distributed energy resources, the role of distribution companies, as we see, expands towards optimization of local generation and consumption. So, the situation is already quite complex. Now, what may be the vision for Industry 4.0 in DISCOMs? If we look at the big boxes, the big blocks, that accelerating the digital transformations, then state-of-the-art IT integrated infrastructure, then application of blockchains, then cloud adoption to accelerate IT modernization. As we know that the gadgets that we are now using to handle power are all intelligent with built-in intelligence inside. They are all having IT applications running inside, embedded software, and throwing billions and trillions and terabytes of data every day, every hour, every minute, every second. So these data we have to store properly, and there the application of clouds, both for storage as well as for computing, is very, very important. The other box may be analytics, fueling utility innovation through analytics, because what we do with this data, we have to apply analytics to all these data to bring out, to churn out insightful, meaningful data, because ultimately every data must be used for the benefit of the operations, for the benefit of the consumers, and definitely for the benefit of the business. Harnessing the power of advanced analytics in distribution asset management. Whatever industry 4.0, 5.0, n.0 we may talk about, ultimately we must keep in mind that in the business of power, the basic components like cables, transformers, then switchboards, those will continue to remain. They will become efficient, I understand. They will become intelligent. Their management and control will have to be optimized, but they will remain, because those are the basic essential requirements for 24/7 power supply to consumers. Then digital experience design for the field workforce. The people working on the field must be enabled with data on their hands to enable them to take decision on the edge. Somebody refers to this as decision making to the edge. Ultimately, consumer happiness, 24/7 supply, 24/7 power supply will continue to remain important. If we consider that what may this journey look like, see today's DISCOM and the DISCOM of the future. Today's DISCOM, we may start with, the starting point always will be efficiencies in operation. If the operations in efficiency in operation will always remain a contemporary phrase, always, because it was contemporary in 1940s, it was contemporary in 2000, it is even contemporary today. So efficiency in operation, then technology absorption, utilization of digitalization and analytics, then e-services. These are a few milestones to arrive at being the DISCOM of the future. But whatever we do, as I keep on saying, The continuous value addition to customer with optimization in cost and 24 into 7 power supply. This would continue to remain at the core of whatever application of technology or industry 4.0 we do in distribution of power. Now let us talk about some smart grid applications. Though the smart grid phrase is utilized to mean many things, but according to me, a smart grid is essentially a grid, electricity grid or a power grid with uh, what should I say, IT enablement and two-way communication to have better control and monitoring. We may call that grid as a smart grid. So taking the discussion further, ring main units and pillar box automation. These are very important last mile equipment for power supply. So if these have to be digitalized and these have to be intelligent, then we can ensure faster restoration during outages, lesser truck rolls, lesser carbon footprint, self-healing network, that is one portion of the network getting faulty, the equipment must be intelligent enough to find out itself of the network is milliseconds, or maybe at the most seconds. Then another thing is auto changeover in the LT. Again, a mode of self-healing, but a little bit crude, may not be that intelligent. It is dependent on maybe lesser technologies, but ultimately it does a lot of good to the consumers. Then distribution transformer metering and automated metering infrastructure based smart metering. See, metering at all nodes of the network, distribution transformers, consumers are already metered because that fetches revenue to the power companies. So every nodes, every distribution transformer, every feeder, if they are metered, and these meters, if they are throwing in data, then I have a very good event log report. I have remote monitoring and analysis. I have accurate billing. I have very good energy audit. I have very good capital expenditure and operational expenditure optimization. Though this slide says minimization, but optimization is the right word. Then extensive optical fiber network. Optical fiber network, the significance of this optical fiber is that the communication network, normally power distribution companies, it is not their core business to have their own communication network. Communication network may be availed of as a service from the telcos. But going forward, since communication is going to play very, very important roles, many distribution companies worldwide, they are trying to own some communication network of their own, so that SLAs are in their hand. They don't have to depend on telcos to bring value or to get value in the business, or to bring value to the consumers. But the idea remains better remote monitoring and control, last mile visibility, less dependency on telcos, as I told. So overall, a holistic integrated approach across the value chain. Now, another thing would become very important is the decision on the move, the faster network visibility and control. So now many discoms, we started using these numerical technology protective devices way back in the 1990s. Many discoms are now using, rather most of the discoms are now using only numerical or digital control and protection. This provides protection in a better fashion. The one box can serve many protections, control as well. These are both way communicable. You can dump setting on these protective devices from remote. You can fetch disturbance analysis records from these protective devices. You can take decision faster. You can get all this data on your mobile even, while the operating engineers maybe for a better work-life balance, maybe enjoying a movie or having dinner at a restaurant, the protective devices may on their own push notify to the uh, pre-assigned mobile phones or tabs or whatever, that okay, this portion of the network some protective device have operated, say the red phase to earth fault has occurred, so much of kiloamperes is the fault current, so much of milliseconds it has taken to isolate itself. So the operating engineer knows which part of the network is faulty. He or she may take corrective action, restore the other portions of the network, and so on and so forth. And also similar kind of functions, they are given by phasor measurement units. It gives more situational awareness, better visibility of the power system. Just one point while I'm discussing, normally phasor measurement units are extensively used by transmission companies because they operate on a very, very wider canvas. But now, since distribution networks are also becoming very complex, many discoms are thinking of operating distribution, not operating, installing phasor measurement units in distribution networks as well. So CSC normally is has always been a front runner in adopting technologies, and for the last 2 to 3 years we have already installed phasor measurement units, and we monitor our network through such kind of devices. Now, asset health monitoring, however advancement we make in industry 4.0 applications or smart grid applications, the network, as I told, the cables, transformers, the basic components of giving stable power supply to the consumers will remain these cables and transformers. So asset health monitoring will continue to be very important. And yes, I agree that for better monitoring this asset health, applications of IoT, Industry 4.0 applications, analytics, robotic process automation, all such kind of disruptive technologies have to, or rather continue to play a very important role in monitoring the asset health. We are using drone-based monitoring for monitoring of transmission lines and towers, vegetation management, hotspot, then thermal imaging of substations. Then for IoT sensor-based online surveillance, we are using power transformers into the ambit of online monitoring. We are detecting hotspots, partial discharges to avoid breakdowns. All these are non-intrusive. The assets continue to run while we have a good tab on its health. So now we are trying to shift from a preventive to becoming predictive in maintenance of asset health, thanks to Industry 4.0 applications. Now then, as everyone present here knows that the pilferage of electricity is a concern in our country, not only in our country, in many developing countries. So energy audit and avoidance of, or rather knowing where theft is occurring, pilferage is happening, is very important. So since we need to have measuring devices, that to smart measuring devices at every node of the network. So interval data of smart meters we have to process. We have to do energy audits and analytics to identify the pilfering consumers and the lost pockets, so that action can be taken on ground. The wrongdoers can be booked, and they can be brought into the ambit of official communication, or what should I say, or into the mainstream. This is this data democratization. I thought of skipping this slide, but digital transformations we are all talking about, but one very important aspect is data democratization to enable decision making to the edge. I touched upon it a few slides back, so we can now discuss it in a little bit more detail. See, we are doing tab based meter inspection and meter reading. What is it? People carry tabs. The job orders are there in the tab, assigned to a particular person. He or she can do the meter inspection or the meter reading, enter whatever was the finding directly onto the tab. The tab is connected to our systems, the backend IT systems, directly goes there, all the data. So manpower is optimized, less manual intervention, then no paper usage, and very fast customer grievance redressal. Then metering on the go, one click consumption data, then keyword scanning, voice interactivity, consumer history, consumer location guide. So if this app or this application is in a mobile of our technical person who is visiting site, he or she knows everything regarding that consumer or that particular meter while working on the meter. A few years back, the system was that he or she had to carry volumes of papers or had to make a note of all the data regarding the consumer or the meter which he or she was going to visit and test. Now it's not required. Anytime, any day, anyone can visit anywhere, but have all the data that might be required. So ushering data democratization within the organization. Then we have already piloted. We are utilizing mixed reality and augmented reality applications in the network monitoring, visualization of relay data, fault waveform through HoloLenses, then the real-time disturbance record, then push notification. I talked about a little bit earlier, relay and fault waveform in mobile apps. So it is decision on the move, very fast, helping in very fast network restoration. So SCADA was already there, but SCADA also requires some amount of intervention, manual intervention. So while SCADA will be there, SCADA will become more and more smarter. On this SCADA, the applications of mixed reality, augmented reality will only go on embellishing ultimate value to the consumers. We are working on artificial intelligence, machine learning, and blockchains because as more and more consumers are becoming prosumers, it may be someday, it may be so that the consumers may require to trade between themselves with the discom only having the knowledge of that transaction. So application of blockchains will be there, which will need real-time settlement. Then cloud big data analytics, harnessing smart meter data, identifying and reaping benefit of use cases. 3D modeling of stations, which enables first time right construction, online infringement checking, better visualization, because in Calcutta, land is at a premium. We always don't get land to augment our substations. Existing substations, what we do, we enhance the capacity. In order to do that, we have to do a lot of engineering. Space is not always there for do the right amount of augmentation. We have to do engineering that too, with very little resources, for which to optimize all these engineering and design, the 3D modeling of stations become very important. And also we are working on digital twins, walkthrough experience, remote troubleshooting, better training and safety, then real-time monitoring. Now coming to the virtual office concept, that the customers need not visit our offices. Customers now, almost everyone, they have smartphones. So internet is very easily available throughout the city, throughout a licensed area. So we have digitalized our services, 100% online application, lesser site office footfall, faster application processing, then many channels of payment, multi-channel online payment, increased customer convenience, more digital penetration. Then chat bots, what bot, WhatsApp bot. These provide improved customer engagement and cost optimization. Then the website, the mobile apps, one window solution, better brand recognition. So we have named it as CACE service. It's entire virtual office available on the consumer's mobile. I was talking about Wonder Mail. It is a SMS with dynamic smart link, provides digital payment experience. A lot of people are utilizing this. Then one-stop CAC app, online payment, supply of complaint, billing complaint, AC application. AC application meaning that someone having no AC or one unit of AC or 2 units of AC want to put more ACs. He or she might like to augment the meter or the connection. He or she can apply through this app. Then WhatsApp bot, which is a customer facing artificial intelligence enabled bot, which provides customer support for daily use. Now, the another aspect is robotic process automation. We are now working on developing robotic process automation to replace the mundane and routine activities, and thereby we are working on processes which these robotic process automations can take care of, and the person who was erstwhile involved in such kind of routine processes can be gainfully utilized elsewhere through proper training. So we are working on robotic process automation. We have started though, but we are utilizing it more and more. Then we are working on many models of battery energy storage systems. We have already installed one battery energy management energy storage systems play a very important role in the demand side management, and a host of other activities as well, which is beyond today's scope of discussion. So I'm just touching it, not going into details. Then we are providing infrastructure for EV charging and other distributed energy resources. EV charging infrastructure is going to play a very important role going forward. Why? Because one part is the climatic obligations that we have to comply with for coming from the Paris Agreement and things like that. So electric vehicle is one thing, but from the DISCOM perspective, the electric vehicle charging infrastructure is going to be very significant, because the fast charging thing, slow charging is not that much of a problem for networks. The fast charging, which charges vehicles very quickly in maybe a few minutes, which requires a lot of power, because the entire energy has to be pumped in to the battery of the vehicle in very little time. So these fast electric vehicle chargers, they are going to put tremendous pressure on the distribution network, and which part of the network is having this kind of fast charging happening will always require to be online monitored by the operators, and hence these EV charging infrastructures are going to be very significant going forward. The other aspect that a lot of work is getting done worldwide is that while these electric vehicles having a lot of charge stored inside are idling in the garages during the night time or during the leans when the vehicles are not running, the concept of pushing back power from vehicle back to the grid, a lot of work is also getting done on that. And this journey continues. There are a lot of other things also which I am not discussing today for the benefit of time and scope. Just one more slide I want to show while I'm on the subject is that, see, what are the challenges for Industry 4.0? Everything is fine with Industry 4.0, but to embrace it with all its good thing, all its goodness, we are going to face some challenges. If not, we are already facing some challenges. Some of them are the shortage of skill and the inertia of adoption, then the silo approach, the lack of cultural collaboration, data and cybersecurity concerns, and requirement of large-scale investments. As I have already told during the start of my talk, that the distribution business in our country is fully regulated. So investment, if I need to make, it has to be okayed by the regulator, because whatever investment we do, it has an impact on the tariff for the end consumers. But on the other hand, there is need for rapid and large scale investment. So all these are challenges that we have to work with, or rather work around, to get the benefit of Industry 4.0 applications in power distribution. I stop here, madam. I'll be happy to take questions later on as and when it comes. Thank you very much.
Thank you, Mr. Mukherjee. We can open up for questions for a couple of minutes for you. So audience, if anyone has any questions, please go ahead.
Madam, should I stop sharing or?
Yeah, you can stop sharing. If you don't have any questions right now, we can you can continue putting your questions in the chat.
I'm using a 2-1 stylus. This is
Somebody
invert
speaking?
for the eraser button, and this is barrel. You may have a stylus like this.
Sir, thank you very much, Shushanto. Then if we don't have questions right now, I would request the audience to put their questions in the chat along side in the session during the rest of the session. And Shushanto, if you can carry on with your memento display.
So this is a small token of appreciation from Industry Academy Dialog Forum to Mr. Sanjay Mukherjee.
Thank you, Mr. Rai. Thank you. Thank you once again for the opportunity and thank you once again.
Thanks. Thanks a lot. I will now introduce our next speaker of the day. Let me quickly share back my screen. Mr. Ambarish Ganguly is our second speaker for today. Mr. Ganguly leads the data and analytics practice in TCS Utilities and also the energy trading and risk management practice in TCS Utilities. NASA has also recognized his contribution to data science and acknowledged him as a NASA citizen scientist. He is also an educator on YouTube, and those who have attended Ambarish's sessions, I would say he's a excellent teacher, and he's a dear friend and colleague of mine too. Ambarish, really privileged to have you here. Welcome to this forum, and over to you.
Yes, thank you, Shudeshna, for the very generous introduction. So I will start sharing my presentation. Is it visible right now? Yes.
Yes, it is.
Okay. Okay. So where is it? Okay. 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 Now I will just, yes. So here today's session is on AI for good. Okay. So what we will do today is that we are going to talk about a lot of things, how AI can be applied to social cause for good. So I have picked up certain case studies in which I have worked very closely with. So the first one, what we will do is with a very interesting one, and this is my favorite, that is poverty economics. And many people know about this. And while I speak, you will come to realize you have heard of it a number of times. AI for school donations and how AI will help police to administer better, AI on penguin population, AI on helping underprivileged children to perform well in school, and AI on bees health detection. I will also start just trying to find, anyways, let me go on with the presentation. Okay, So these are real life case studies. And the time invested per case study is 2 months or more, around 60 days. So you can imagine there has been a lot which has been done, but we have limited time, but I want to share with you everything. So what we will do is that we will not speak in detail, but to give you the journey and how in your daily lives, if you see something, any data or something, you can apply AI very well. So the first one is about Kiva. So Kiva is like you can provide a loan to somebody and they will pay you back. But these loans are being utilized by people who are not very privileged. And so the aim of this organization is is very nice, which will come later. But what inspired Kiva is very interesting. So we know that Muhammad Yunus won the Nobel Peace Prize for microfinance, and this lady, Jessica Flannery, heard Yunus speak in the Stanford Business School, and she thought, why can't I uh, give birth to an organization called Kiva Microlender that lends loan money to poor but enterprising people around the world. If you have some time, go to YouTube and search for a Kiva video, and she tells a very inspiring story of she was inspired to start this. So basically, if you go to their website, you can also do something like you can give a loan to somebody in a country. You can give it to a person in India, Nepal, Bangladesh, or anybody, and and they will work on it and they will utilize your loan in some way and then pay you back. So there was this competition which was arranged by Kaggle, which is one institution. So what it is that Kiva provides $1 million in loans to over 2 million people. Okay, so it invited the Kaggle community to help them build more localized models to estimate the poverty levels of residents in the regions where Kiva had active loans. So, what it means is that we are going to utilize AI to identify places where we should give loans. So we would not give loans to people who are living in affluent areas, but we would give loans to people who would be living in non-affluent areas. So you're using data science to do that. So this is like measuring poverty, and this is somewhat related to the work that Abhijit Banerjee had done in their Nobel Prize, somewhat related. So you are measuring poverty. So where are the Kiva loans being used? It's mostly in agriculture, food, retail. Can see this. This is one graphics that we see. So where are the Kiva loans being used? You see a lot of it is in Africa, in South America, Mexico, in the Central America region, India and the Indian subcontinent, and within Europe as well. So how do you measure poverty? This is a very interesting thing. Focusing on income is not one factor in which you can capture the true reality of poverty. So a person can have different disadvantages: poor health, malnutrition, clean water, electricity, poor quality of work, or little schooling. So there is a measure which is called a multidimensional poverty measure, which is used to create a comprehensive picture of that. So this is one measure that we would use. So so the data was given and we plotted it. And so this is a geospatial map. So in the geospatial map, you can see that the higher the MPI, the multidimensional poverty index, the redder is the region. The more red regions are very poor. So the red dots indicate that the country is poorer. So this is where we should give the loans to the people. So the intention of this exercise from a data science perspective is to identify regions where we should give the loan. So most likely we would give in countries where these people, the poor people, reside. So this is one measure which we can use. Another is called the Human Development Index. Also, you can also see the African region has very low HDI, and this is where the Kiva should focus on loans in this belt. Now, there is also another measure called the population under poverty line map. So you see also in this map, Syria, all these regions in Africa, they are the highest population below poverty line. So what I did, this was a competition, was that I created a metric, which is a very naive approach, and we created using these three uh, matrices that are there. So these were the data sets that we got from Kaggle and from various places, and we combined them and we created. So you can name mine. I just named it just like that, AG poverty metric, and this can be used by Kiva to identify that places where we could give the loans. So this another approach is that we can do using the DHS cluster. So what is a DHS cluster? So there are surveys which go on, the fertility surveys, health surveys. So those have little information on economic status. So there is another index known as the DHS Wealth Index, which also accounts to determine the household's relative economic status. Why this is important is because what we will see in this second approach, if we have the latitude and the longitude and we have this DHS wealth index, we can identify the DHS cluster. So why this is good is because what is happening is that within India now, if I have a latitude and longitude, I can use this data. If I have this latitude, longitude, and the DHS cluster, given a latitude and a longitude by modeling, I can predict the DHS cluster, which indicates the asset indicator. So in this way, we can pinpoint the areas where a Kiva loan can be given. So this is about the Kiva loans. The next case study is all the more interesting. This is about an organization called Donors Choose. So what happens is in Donors to Choose is that um, teachers and students, when they're in a classroom, there is a lot of material that is required. So those who are teachers would know that you require books, cleaning supplies, technology, and various other things. So what this organization does is that the teachers would put up their request that I would require this donation to support a classroom, and then donors like us can support the teachers by giving donations for their projects. Now, what happens is that what they have seen is that people donate, but they donate only once and they forget about it. So, as to encourage the donor to donate again, what they wanted is to do an Amazon or a Flipkart like experience, meaning so you have donated, say, to a science project. So you will be sent a mailer for a science project. If you have donated for a project for autistic children, you will be sent a mailer to support autistic children. So that is a recommendation system that they are trying to build. So a little bit more about Donors Choose. So it was founded in 2000 by a Bronx history teacher. That Bronx is in a place in New York. So this is mostly for US. So US, one thing is good is that a lot of data is available. So what is it that today 3 million people and partners have funded 1.1 million donors choose organization projects. But teachers still spend more than $1 billion of their own money on classroom materials. Very interesting. So, what to get the students what they learn, the team at Donors Choose needs to be able to connect donors with the projects that most inspired them. So, they are connecting the donors with the projects. So the competition was to connect the to recommend the donor to the appropriate project. So here we see the distribution of the donation amount. So it's around $25 is a median, and the max is around $60,000. So this is the distribution amount. Percentage of donors, more than 72% donors donate only once. So this is not good because we want people to donate more. And once they have donated once, we want to encourage them to donate more. That's why this project was undertaken. So this is US based, and so where are the most donors? California, the most of the donors are here. So this is a geospatial map in which we are seeing it. So if what the information that we had is this, we had the donations, we had the donors, we had the projects, we had the resources, meaning which resource was required for the donation. Maybe it can be a set of pencils, set of crayons, maybe a drone, maybe some scent, some soothing oil, some whatever it might be. So these are the resources. We are the teachers and we are the schools. So this was the information that was given to us, that is the data that was given. So how can we use it to make it so that I can connect the donor with the project? So what we did was that we had these type of approaches. We use a non-text features, category, subcategory, grade, resource category, school state, and prefix. And we use these features. And another approach was using only the text features, and another approach was using both the non-text and the text features. So this is how we had used it. So just to show off how we did it, I'll just go through very quickly a very simple concept that I had used for that. So here, if you imagine that this information is, since this is an IEEE conference, it's easier to speak in maths. And so this is like a vector. So this is a vector. So you can represent this information as a vector. So if it has got 2 points, then it is a 2-dimensional vector. If it has got 3 points, it is a 3-dimensional vector. If it has got n points, it is an n-dimensional vector. So all this information that was there is an n-dimensional vector. And then what we did to calculate this similarity, we used a very simple concept. We used a cosine between the two vectors. Why? Because cos theta, cos 0 is 1, and cos 90 is 0. So if it is two vectors is 0 when they are very dissimilar. So this is all the maths and whatever, but basically this is the formula, and we are measuring of two vectors, and this is how we did it. And we found that this approach worked very well, and we found that the recommendation using the non-text features uh, were the best uh, compared to all these other approaches. And so this was a competition. So this approach won a prize. So this was well appreciated by the organizers. So this is how you can use very basic data science, vector algebra, and recommendation techniques to use in school donations. Okay. The next one, what I would show you is that another interesting case study is that for Center for Policing Equity. So what these guys do is that they comment on on the policies that are made by the government. And why it is important, because this is American organization. So they have felt that if you're black, you are 2 to 4 times more likely to have force used than if you are white. So, working directly with police to measure behaviors and to revise policies results in fewer people killed and fewer people in jail. Mind it, this competition was done long before that incident that occurred recently with police interfering with the black population. So, people knew of all of these things. So, this initiative is going on for a long time, and they had this competition long before. So, what they wanted to do is to educate the police with data that how you should behave with people so that you can limit the number of crimes, but at the same time be respectful to race. So we'll go into what this competition is about. So, how do you measure justice? So, these are very abstract things like poverty, justice. How do you solve the problem of racism in policing? So, we look for factors that drive racial disparities in policing by analyzing census and police department uh, deployment data. So the goal is to inform police agencies where they can make improvements by identifying deployment areas where racial disparities exist and are not explainable by crime rates and poverty levels. So this organization needs to tell police of where to deploy forces, of how to behave, and in a region where to concentrate your police forces. But the problem is that the data which is there is all in a very unstructured state. It is not very structured data. There is police data that is there. There is census level data. There is geospatial data in the form of shape files in maps. So how we did it, it is very interesting. So we had these types. So shape files, census data, US Census tract shape files. The problem is that the police district shape file boundaries do not completely map with the US Census tract shape files. So there is not a one-to-one mapping there, and it is quite difficult. So what we did in this competition is that we tried to visualize it first. So this is one of the regions. So these are the regions. So this is one region, the Epic Fair Park. And then what we see is that the white population is more in this police district one, but the crime is more with the blacks. You see here, the white is more, 60%, but the black crime is more. So why it is happening? So if you look at it, so this is a geospatial visualization that we did with a lot of calculations, and we came to this measure that if you see that the increased black population, see the dark region around here, this is black population being increased, and it is also with the poverty, uh, higher poverty. And if you see the black population, also you see that it is having a very low high school diploma completion. So you see here the population, the black population, poverty, and less literacy, and this varies across regions. So what we are saying to the police is that don't just go ahead and arrest the blacks. There can be more poverty there, and so understand the situation and do. And the deployment should be in this structure, meaning you have this structure, the shaded region, and you can do where places there is more poverty, there can be more crimes, so you can deploy in this region. So this is another same thing, same pattern is existing, like the black region, more poverty, less high school uh, completion. So these were the things that we are seeing in different places. So these are the different areas that we did, and this keeps on repeating. So what this submission that we highlighted was that applying policies uniformly across a jurisdiction is not always effective, even within a single precinct where race and income variables vary greatly. So there is this kernel over here, this link. You can see all the code as well as all these visualizations over here. So in summary, what are we trying to tell to the police is that don't deploy your forces in one location, spread it according to the population, to the poverty, to the high school completion thing. So this is a guidance, and moreover, be a little bit considerate that not more many people are literate, so they may be speaking to you or they may be interacting with you in a different way. So you have to be a little bit more considerate with them. So this is how, this is not a prediction problem, this is more of an analysis problem. So this is how we guided through this submission the policymakers, how they can guide the police to do this. So this is also one prize that is given. Another thing, I just wanted to do a time check of how am I doing. So I think that is fine. So we are doing
Yeah, it's
okay
fine.
with time. Hmm. So so this is about predicting the penguin population. So so here this was one competition in which we had to predict the penguin population. So this is very interesting is because penguins population tells us a lot about the general health of the Antarctic, because penguins are important krill and fish predators. So because once these fishes and all these other things are limited, then the climate in Antarctica changes. So it is very important from an ecological point of view to to predict this penguin population, and they are very important ecosystem indicators. Okay, so that is why a lot is spent in penguin population. But the problem is the data collection of this penguin population is very limited. So I know of ecological researchers who would go to Antarctica. You can imagine going to Antarctica is not only very costly, but also you require a certain amount of physical fitness to be there. So to count penguins, and nowadays drones are there, but still I think they go on expeditions to Antarctica. So this competition was to predict the penguins and how we can go about doing it. So I don't know about you, but I thought Antarctica was one island, but actually Antarctica continent is made up of different islands, a lot many islands, and there is not only one type of penguin, there are different types of penguins. So these are the different types of penguins. I think there are more different types of penguins. And the penguins are very different in species are different. They breed differently. They live on different islands, so they have different ecological diets, and so it is not very easy to have a simple model for each penguin population. So so they invited the data science. So this community which launched this competition was all ecological researchers. Now, they launched this competition to people like us who are not ecological researchers, who are not absolutely related to ecology, to have an outside view of how we would think about this problem. For me, I did not know about penguins, and there is a lot of factors there, some biological factors, some ecology factors are there when you should do the prediction, but I did not know it. But they actually wanted to see of how we would approach the problem. So we took a very statistical and very mathematical way. So for us, it was like a time series problem. So the time series problem is like this. So this is an island. So there are many, many islands. So this is a site ID of the islands. Then this is a penguin which is there. And then this is a years which are being given. So they gave the data from around 1900s to 2013. And we were asked to predict the penguin population for 3 years. 14, 15, 15 16. So this was the data that is given. You see that the data, the problem with the data is NaN is not a number. That means they do not have data for this. So most algorithms or time series algorithms do not like if the data is not present. So that is, so many, very many data scientists were actually not very comfortable with this problem. So this is about the cross-sectional data. So these are time series data. And so time series data is that you take a series of measurements over time, and you have to, we treated this as a time series forecasting problem. So this is a forecasting process. I will not go into deep into this. Maybe in a separate lecture we can go of how we can do this. So first is you get the data, you visualize, and then you partition the series, you apply forecasting methods and do all these kind of things. So I just want to give you of how the data was given. So it is like this. So this is the site ID, the name of the penguin, and so they were asked to, we were asked to predict this for 2014, 15, 16, and 17. So we were given data till 2013. So this was the problem statement. So these are various measures that we had used for predicting the accuracy. So I will not go into detail on this. But I just want to tell you of how the solution was made. The solution had two components, which is one is the imputation, which is a very fancy name for filling up missing data. These algorithms, as I was saying, is that they are notorious. If you do not give proper data, they will not give you proper results. So this is where the model which I had developed excelled from other models, is that it gave proper imputation, and we filled up the missing data, and then we did the model building. So in the imputation, we had different types of models. These are language specific models, R and Python. During the time that I was doing, I was not very conversant with Python. So I used R, and time series models are good in R. So here I had used all these interpolation techniques, Stein interpolation, last observation carried forward, next observation carried forward, replaced by zero. Most of these interpolation techniques are very easy to explain. The replace by zero is very simple. It is just if you find a missing value, you just replace it by zero. And these two also I'll explain in the next. And Stein is another interpolation technique, which is an advanced interpolation technique that was used in this. And then these were the imputation techniques that were used. So this is a paper which explains Stein. So I had used the library, but what they have seen is that Stein is very much reliable when the data is not very good, and it is better than a linear interpolation, and is more reliable if the variable presents abrupt changes in slope. So this one was used. And so if the last observation carried forward It's a very simple thing. It's much more easier. So if you have something that is not there, you just replace it by that. So 6 is here, you replace it by 6 here. And the last observation carried backward is that you replace the backward value 7 here. So this is a 1. So these are easy. And this was some code which actually is the details of it. But eventually, what I wanted to say here in this is that if you see the implementation, it is very simple. Once the intention is not to bog you down with code, but the implementation is so very simple. This is a heart of this implementation. Only thing is that it takes care of error handling in a very nice way. So um, it has a lot of exceptions coming in. So that's why this code was able to work very well and used ARIMA here. I had used also Facebook time series algorithm called Profit. Do check out if you're interested in time series forecasting. I think Profit is changed or they have come up with a new version. So, so what the model was done is that there were 648 combinations of penguins and islands, right? So why it is 648 is because if you see here, so this combination of a site and a penguin, there were 648 combinations. So instead of having a single model, what I did was that create a model for each row. Though it might seem that it is very difficult to do, it's actually very easy because I would just run it in a loop. So for each of the 648 rows, I had created um, 5 models. So these are the models. So if you are interested in time series modeling, please do check it out. These are very fantastic algorithms: ARIMA, ETS, Profit, and XGBoost and Random Forest. And then I took a simple mean of that. So this was the solution, and fortunately, it won the prize for the competition, the first prize. So there is a blog out here. I will, and this is also the code is given, and the publication has also been done with the organizers of the competition. And this is one of the great books which I had used. So this is all about the penguin competition. And this was later on, I had worked in projects with other ecological and seabird researchers. So that was the one this was sponsored by NASA, this competition. Another competition, which is, it's not a competition, it was, um, this is a case study of where we are detecting the health of the bees. And why health of the bees is important is because I didn't know this. Every third bite of food relies on pollination by bees. Honey beehive losses are quite prevalent due to the diseased bees, and it is very difficult to check the health of a hive by going into the hive. So it's rather easy to see what are the bees that are coming out of the hive, have pictures of them, and to know that whether the bees are healthy or unhealthy. So this was a data set that was contributed by a beekeeper, and obviously these beekeepers were very nice. They contributed this data set of images, and I had used these images to use. It was a custom vision service in Azure. Azure is Microsoft's cloud. So there I had used custom vision computers services to detect the healthy and the various types of diseased bees. So this is more of a different type of problem. Here I am trying to use images to detect whether it is healthy or it is unhealthy. So this is all about the healthy and the unhealthy bees. And this is the data set that is there. And I had used a much more smaller data set. And these are the steps which maybe on a separate lecture, we can go through them and demonstrate you how we did it. But essentially what it means is that using these new technologies like Azure, and they had wrapped up these complicated things which you had to write a lot of custom code into very easy APIs so that it comes in the hands of very ordinary developers, and you can use them to create models. You don't have to know a lot of data science, but it is like citizen science. You can use it and you can create this type of projects and make it very easy. So the last case study is about an organization called Pass NYC. So what they're doing is that they want to give coaching to the talented people but undeserved students so that they can ace in their SAT test. So it was an appeal to the data science community that here is the data that of schools, of the test takers, of their scores and everything. Can you help us to identify that where we should deploy our volunteers so that they can coach effectively, meaning that they should coach only talented people, but not privileged people. So talented but undeserved students. So how are we going to do it? So the data science community used this opportunity to identify schools. So there is a lot of data sets that was given. So these are, so there is also a safety report. So you could see that certain areas were very crime prone, and so you would like to help in those areas also, because people they are studying hard and they're talented, but somehow the safety concern is there. So that's why they may not perform well in tests. So they require more help. So this was a data set that was given, and all of the data set is in Kaggle. So we found that by modeling that the average English language ability is dependent on these factors, like a student attendance rate, supportive environment percentage, effective school leadership percentage, rigorous instruction percentage, and all these things. So basically, what I want to tell you is that through the use of data science, through the use of AI, we could understand of how the student's ability is being handled by these factors. And then we came up with a ranking system with different, so 18 features were identified, and we use this to help rank the students. So this is the end of all the things. Hopefully, I have covered the time, and I am now open for questions.
Thank you very much, Ambarish. Excellent set of case studies. I think you can go on more and more for each of them individually,
Yes.
but we will be running out of
Yes.
time, but I think we are well within
Yeah.
time. And so let us open the forum for questions from the audience. Okay, if nobody has a question right now, we can post the contact details of our speakers in the chat today. Nilanjan,
Yeah,
somebody
good
was
afternoon. I have a question to both the speakers. Means uh, AI for good and applicability of Industry 4.0 in power sector. Both the speakers have covered their topic extremely well. my question would be, what would be the impact of Industry 4.0 and AI on the job sector in particular? Means it appears that it will create enough job opportunity for people with technical skills, but on an overall level, how how these things are going to impact the society, if the speakers can comment on this.
Is I'll go first if there is some problem. So one thing that is there is that AI for good, what we have seen is that now AI is now in the hands of every common person. So what is happening nowadays, if you see, like many organizations like Microsoft, Google, AWS, they are allowing AI to you can use it without knowing the internal details of math, science, and all these things. Suppose you are a farmer or you are a very ordinary person in agriculture. So how can I improve agriculture? So those things are becoming more easy now. So just the example that I gave for the bees, right? I did not have to use any maths or anything. It was just an API call. So to be very honest, nowadays everybody now, a class 9 standard student now is now coding, doing programming. So now everything is now in the hands of every common man. So if it can be used like this B example, I'm very amazed that this was done by a student who actually is doing student is a student in some university, and his pastime is he or she is training to be a beekeeper, right? So they are utilizing it. Maybe this is not very common in India, but I think this will become common. Previously, as you had seen, mobile phones were very costly, right? Very few people during my student days had a mobile phone. Even during my early career, very few people had a mobile phone. Nowadays, everybody has a mobile. I am foreseeing that this AI is not something very fancy or something like a Rolls Royce car or something. It is going to be in the hands of every common man, and we are going to utilize it without even realizing that we are using it, and it will go embedded in it, and it will improve our lives. The more we embrace it, I think it will there will be several job opportunities at different levels, maybe at the very high profile scientists and all those levels, as well as people who are operators of this thing. So there is a lot of opportunity. And as our previous speaker, Mr. Mukherjee, has said, now in electricity utilities industry also, there is a lot of opportunity.
Okay, okay. Thank you, sir.
Nilanjan, if I may add, while I entirely agree with Mr. Ganguly, just one view from my side is that, see, from a discom perspective, since I covered it from that angle only today, Industry 4.0, whatever young engineers today are joining our industry, they are much more savvy in utilizing these modern day 4.0 applications, and the good or the forward looking academic institutions, they are more and more covering these kind of subject matters in their curriculum. Another thing is that even if it is not in their curriculum, it is getting embedded more and more into everything. Suppose today, if one engineer is expected to know something on transformer, he would also be expected to know how industry 4.0 or IoT can gel with the basic transformer technology and make it more visible, make it more what should I say, controllable, more utilizable, and so on and so forth. So that is one part. The other part is that since AI unknowingly or knowingly, consciously or subconsciously, these new robotic process automations, artificial intelligence, all kind of these new technologies, IoTs, are slowly now already getting inside. every aspect of human life. I'm now outside the distribution companies. Say you are now, while you approach your home, you want to switch on your AC from outside. While you leave your, or you're approaching your office, you want to switch on your desktop. All this can be through IoT technologies, but someone else will be working behind, which will definitely go on creating job opportunities at a different level, which you from your work area may not be able to see, but those will go on creating job opportunities. And another thing is that on a philosophical level, if the right time is ripe for application of these kind of new technologies, then the society, the industry, entire economics will realign everything so that there is harmony in the society.
Okay.
Nilanjan, that's
Thank you,
all.
sir. Thank you.
Nilanjan, hearing out Sanjay Mukherjee and Ambarish Ganguly, it reminds me of a very glaring example in North America, where both transmission distribution and AI for good comes together, like the wildfires which happened in California. A small simple sea hook or sea loop, whatever it's called, I forgot. The brittleness of that was the main cause of that fire, that sea hook broke down, and the transmission line, which is near a forest, which has the environment, which can have a certain climatic conditions. And what is the predictability around that, that next year we can avoid that? So whatever Mr. Mukherjee was talking of asset health maintenance, as well as the drone services that we are using for transmission distribution, AI work that we are doing, and everything about utilities, everything about whatever we are doing there is so much directly impacting human life. So I think, yeah, it was a two very distinct topics, but very connected topics we covered today. So any further questions from anybody?
Yeah, actually, I have a question for Ambarish sir. Actually, it's a query from my friend. Yesterday, he was calling me and he was asking that he's a commerce graduate. He did his MBA after that, and he is asking that whether he can pursue data science through some program, and what is the job opportunities that he can get after completing the data science program or any course. So, sir, if you can kindly help.
Ambarish, we can't hear you.
Oh, sorry. Now you can
Yes,
hear
yes,
me?
now we
Oh,
can hear you.
somehow this thing got muted. So as far as course is concerned, I may not be able to tell you, but if you're a self-learner, now it is become very easy. The easiest way is to learn any programming language and then carry on with any course nowadays which is available in Kaggle. I always recommend Kaggle Learn, which is a very structured course is there, in which you can learn programming, in which you can learn machine learning, deep learning, everything with easy exercises you can do. And there are YouTube videos of many people who are doing it. And then you go around and make a portfolio of projects that you can do. There are competitions, so you make your own portfolio. And after that, to be very honest with you, uh,
Yes,
I
sir.
would say that he has a good combination. Being a BCom graduate, he has a knowledge of finance, which is very important, a domain for data science, marketing, and all these things, which are very ripe areas for that. So the opportunities are endless. Only thing is that people may not give you immediately a job. So you have to work a little bit. Maybe a course from any organization, reputed organization, might help to put on CV. But ultimately, at the end of the day, if you know the things, And if you are a commerce graduate, you must have done some mathematics and statistics. So please brush up on that. And if you have a fair sense of that, it is easy for you nowadays to get a job. Only thing is commitment, time. So I would encourage to go ahead and do.
Thank you so much, sir. Actually, it's a genuine question that came to me from my friend yesterday, and I'm attending this webinar. So I'm really very much fortunate that you have answered that query, and I can convey it to him. Thank you, sir.
Most welcome.
And Ardhindu, this is a very typical trend of even students from non-STEM moving into data careers. And I can give one example that's very common in IT industry. We have functional consultants in finance. A very typical career path is when they want to move into data analytics, they usually start with visualization on financial systems, which is very relevant to their background.
Okay.
Slowly, they move into risk modeling and typical predictive analytics and advanced analytics and data science work on finance. So then they evolve out to be a techno-functional person, which is a very strong background rather than, I would say, pure play technical skills. So you can guide him through that path so that his experience is of relevance, his skill set is of relevance to him.
Okay, thank you very much, ma'am.
Okay, so if we don't have any other questions, then Shushant, over to you.
Thank you, madam. Here we have a small token of appreciation from Mr. Ganguly.
Thank you.
Is it visible?
Yes,
Right.
yes, it is visible.
Okay. So
Thank you. Thank you, everyone. And if possible, if all of you can come on screen once, we would like to take a snapshot.
Yes, I was actually trying to come on screen, but somehow I was unable to do it during the presentation.
Just a minute. Is it coming or?
Shushant, you are not showing on video.
Okay. Not- Is it okay?
Okay. Yes, it is okay now. Okay. So we will be closing the session now. Thank you, everybody, for joining
Thank you.
these of events are following. Thank you, everyone.